Good morning to all of you. This is Chandan sir here one more time. Now today we are going to discuss about the subject called chemistry. In chemistry is a very important topic is there what is called ionic equilibria. So let's understand the ionic equilibria. Before to understand ionic equilibria in entirely, let's understand a few concepts. First of all, what is this exactly? So let's understand a weak acid. Whenever a weak acid, a weak electrolyte is dissociated in aqueous solution, and some of the molecules ionize to form the ions, and some of it remain unionized. And the equilibrium that is established between ions and unionized molecule is called ionic equilibrium. Now, to understand this in a detail, let's understand the few concepts like for the acids and bases. The first one is Arrhenius. Arrhenius theory, it came into the existence for the in the year it came into existence in the year 1884. He defined the acid as something. Which produces hydrogen ion when it's dissolved in water. So in aqueous solution, it produces the hydrogen ion. And then, for example, if you take the hydrox, beg your pardon, if I do it in the back. Okay, it's okay. Okay. If you go to the back and if you see the example like this, HCl in aqueous solution, it dissociates into the hydrogen ion and chloride ion, and in the aqueous solution, remember that I'm talking about, and similarly here also. So it is giving you the hydrogen or hydrogen ion. So what is happening is next is, what about the base? The base, as per the Arrhenius, the base is something which produces the hydroxide ion, in aqueous solution. That is called the bases. For example, sodium hydroxide, it gives you sodium ion, which is positive ion, and hydroxy ion, which is negative ion in aqueous solution. I'm just writing here, and if you want to write here also. So hydroxy ion. So this is how it works with the hydroxy ion and all the hydrogen and bases. So according to the Arrhenius, the concept of acid and bases, the neutralization of acid with a base involves the reaction between the hydrogen ion and the hydroxy ions, which is give you the water molecules. So this is what exactly happens. But the problem with, there is some limitation. There is a limitation in this theory, in his theory, and let's understand this theory in more detail. What was the limitation? For acid or the bases, basic properties, the presence of water is absolutely necessary, right? As I told you, it was the aqueous. In aqueous solutions, it means the water. Dry HCl has not acts as an acid, and HCl is regarded as an acid only when they dissolved in water and not in any other solvent. So this is the first drawback is water is absolute necessary condition. Water is absolute necessary thing to declare that whether it is a acid or a base. Second limitations comes like this. Second one is this. The concept does not explain the acidic and basic character of the substances in non-aqueous solvent. Understood? So it cannot explain the acidic and basic character of the substances in non-aqueous solvent. Third one, interesting. It cannot explain the acidic character of a certain salts like SaLCl3, aluminium chloride, or ferric FeCl3 in aqueous solution because it does not contain any hydroxy or hydrogen ions. So you can't say whether it is acid or base. So this is one of the major drawback of this theory, of his theory. Okay. The next one, an artificial explanations to required. Remember that there is an artificial explanation is required to explain the basic nature of sodium ammonia and the metallic oxide and the acidic nature in the non-metallic oxides. So the artificial explanation is required for the ammonia. So you can't easily say that it's nature. And metallic oxide also, metallic oxide, as we know that metallic oxide is a basic in nature, but it's very difficult to explain with the help of this example. So I hope you understood the Arrhenius theory for the water, Arrhenius theory for the acid and bases in this module. Thank you so much. Have a nice day.